algorithmics and Pascal coding. If I ask you to define me an algorithm, what would you reply? Algorithm. Define an algorithm, please. Series of instructions, yes, to perform, yes. So you are defining this algorithm with regard to a computer, but algorithms actually were defined centuries before that, before computers. Computers exist since maybe 5 or 6 decades, but algorithms existed centuries before. I was like saying thousands of years before. So what is an algorithm without thinking to any computer, any machine? No. If you talk about instructions, these are two computers. When you say instructions, we don't define a priori an algorithm through instructions. When you say instructions, this is with regard to a computer, okay? So, can you change the word, the term instruction, but by something else, by another term? Yes, yes, steps. So, how do you define an algorithm? A series, you said, or a set of steps? And then, for what?
To solve a problem, mathematical problem.
Yes, yes. Not a mathematical problem. It could be a problem in physics, in chemistry, economy, in any field, any other field. So an algorithm is defined instruction. Can you see? I'm looking for my whiteboard. It's here. Okay. So an algorithm, can you see the whiteboard now? Do you see the whiteboard?
Yes.
Okay, okay. So an algorithm can be defined as, and not any steps, ordered steps to solve any problem, okay? For example, solve the equation ax squared plus bx plus c equals 0, okay? What are the different steps? Let me just write it. I want to save the equation ax squared plus bx plus c equals 0. In order to solve it, you need to respect the steps of the algorithm. When you say an algorithm, this means step by step. The third step could never come before the second step, okay? And so, an algorithm is defined, can be defined as a set of organized and ordered steps to solve any problem. We have chosen this problem, okay? If you had to compare an algorithm to something else, you can compare it to what? Yes, okay, very good. It can be compared to a recipe. What is a recipe? What is a recipe? A cake, let's say a cake. A recipe, for those who don't know it, is recette. Let's say une recette de gâteau, okay? Who don't understand, please do not hesitate to ask the question in order that I translate in French, okay? I translate to French. So, I have the recipe, and on the other side, I have the algorithm. So when you start with a recipe, you start by what?
What's the recipe?
This is the recipe. I have just explained. A recipe is une recette de gâteau, une recette de cuisine, par exemple.
The name of
This,
the recipe.
yeah, okay. So the best example is this recipe, and I will explain why. When we start with, so we'll just compare. When I start the recipe, I will say recipe of what? Let's say a cake. So this is, let's say, the type, okay, of the recipe, right? For the algorithm, you always start with the title, okay? You write algorithm. Here, this is just the abbreviation. And I start with the title of the algorithm. This is an algorithm to solve, for instance, the equation that I have mentioned here, okay? After this, I need to separate all the instructions by this punctuation, okay? So, by defining your recipe, you start by what?
The ingredients.
Ingredient.
Ingredients. Let's say you are answering for the algorithm, but here for the recipe, we start with the ingredients, okay? Right? Right or no? Okay, let's say the ingredients. Give me just examples of ingredients. First example.
Eggs.
Yeah, you can say flour. You can say also eggs. And since it is a cake, there is something, yeah, that we should not forget. Sugar. These are the ingredients. These are my ingredients. On the other side, what are the ingredients of an algorithm?
The variables.
Variables, I don't agree with you. We say objects of the algorithm. Why objects? So here I'm supposed to underline here. Why I say I have to identify the objects, because among these objects you can have variables and you can have constants. You can have constants, and we define the constants before the variables. Explain why. If you say a variable, what is a variable? Let's say here, we don't know that we have to define the constants before. So let's say, okay, variable. So just after this title, you need to start a declaration part. Okay, declaration part. What is the declaration part? Or for any code, Pascal code, C code, Fortran code, any code is supposed to start with the declaration part. This is, it could be the most important part of computer science. Why are you supposed to start your code or your algorithm with the declaration part?
Because all the rest of the instruction will depend from them.
Yeah, for sure. The rest of the instructions will depend on this declaration part. What do you do actually with your computer? What happens actually with your computer once you have finished your declaration part? What is the declaration part? I will give an example. For instance, you are traveling somewhere and you need to book a hotel. You need to book rooms in a hotel. What do? You call the reception. And at the reception, what do they ask you usually?
Identify yourself.
Yeah, you identify. Of course, you will identify yourself, but and then after that, what do they ask you at the reception? You are trying to book room or rooms at a hotel, at any hotel. What do they ask you?
What kind of room?
Before that,
When you coming?
yes, and then yeah, some more important questions.
How many?
First questions.
Are you alone?
Yes, yes. If you are booking online, for instance, the first question they ask you, if you are alone, if you are with someone else, and to sum up this, how many people you are, in order to know how many rooms are needed, are required for your stay in this country, for instance, or in anywhere. Okay, so how many people you are, and then they will ask you if there are some children or some adults or some old people with you. Okay, these are the kinds of questions that are asked. Here, for the declaration part, with regard to an algorithm or to a computer, a Pascal code, for instance, you start with the declaration part because you declare you will book rooms where. If you are declaring something with your computer, you are doing something else. So, memory of your computer. Okay? And I will to this memory. This is the memory. Why do we start with the declaration part? Your memory actually is constituted of several memory cells. These are memory cells. I repeat, if you don't understand, I French, okay? Because a priori, I want to teach you algorithms and coding before English, okay? It comes before English. So this is your memory, and these are memory cells. This is a cell, okay? Once you start, you will start to book cells in this memory. And if you declare a constant, why do we start with constant declaration? If you declare a constant, your computer will put it here, for instance, let's say A, and this cell memory will be locked during the whole running of your code, okay? So constants corresponds to locked cell memories. Do you understand this?
Yeah.
Okay. What about the others? Do you understand this?
Yep.
Okay. So your computer.
No.
No? Okay. Do you need me to repeat it in French?
No.
Okay.
Just repeat it in English.
So when you declare a constant, this means that your computer will book a cell memory that will be locked. It is locked means la case mémoire sera verrouillée. Elle sera verrouillée pendant tout le programme. Ça veut dire que je ne pourrai pas l'utiliser pour quelque chose d'autre. I am explaining. the difference between declaring a constant and declaring a variable, because most of you told me that we are supposed to start with declaring variables. No, we declare first the constants in order that your computer assigns cell memories to these constants, and these cells will be locked during the whole running of your code, the whole running of your program. Is it clear? Explain.
Yes, ma'am.
This is just to explain. We are obliged to start with the declaration part in order to assign cell memory to all the variables and all the constants. If you forget to declare anyone, okay, let's say anyone, any objects, the code will not run, will not be able to run.
Yes, ma'am.
Yes, yes. With all languages, this is valid for the algorithm. I intend to teach you algorithms and how to use algorithms and how to talk to your computer, okay? Once you have understood how do the algorithms work, you will be able to code in any language. This is valid for Pascal coding, for Fortran, for Java, for Python, for any other language, okay? The rules should be respected for any programming language, okay? Because you have your code, you have softwares, but you have the hardware, and in the hardware you have this memory that is you cannot run anything without this memory. This represents the stadium, let's say, of the football match, okay? If you have a football match, you need a stadium. The more you increase the space of the stadium, and the more the players will be able to play easily, okay? So yes, did I answer, or maybe I misunderstood? No, even no, it doesn't depend, because even with Katya, I will ask you the question. I have lost my whiteboard. Okay, it is here. I will ask you a question. Even if you run a Python code or any high-level language, where do you run it? What do you mean by ID? On a computer, for sure. A priori. I'm asking the question. Yes. No, we're not. We're, yeah, sure. But anyway, in any language, and even with high-level languages, you need this memory. This memory is part of hardware. And any high-level language will need it to work, to run, okay? So I'm explaining that it doesn't depend. I will talk about compilers and about machine languages, and so I intend to talk about that. But what you need to know is that your code will need this space. If you don't have this space, no one of any high-level languages will be able to run. Okay? Okay, so I will go back to these ingredients. So first, I will start to declare. What should I? Maybe I should. Okay, I will have to explain something before that. Before going back to the algorithm, puisque Katya a parlé des high-level languages. Okay. So You have, if you want to write a code at any level, okay, before writing your code, you need a sheet of paper, okay, unless you are very specialized in coding, okay, unless you are a professional in coding. But for anyone else, you will have to take a sheet of paper and to write your algorithm. So this is my algorithm. So in which language is written the algorithm? This is my algorithm. In which language you are supposed to write the algorithm?
English.
This is my algorithm. Yes, what did you say?
In English.
No,
Basically in English.
not in English. Not basically in English, not generally in English. In which language is, yes, what do they call it in computer science? I try to open the text box.
Pseudocode.
Excuse me?
Pseudocode.
Yeah, it is a pseudocode. The algorithm is a pseudocode. But in which language is it written? Written in universal language. And I will explain why universal language. Universal language. Why? The algorithm is usually written in a language that is called universal language. Why?
Because it's universal and everyone could understand it.
Yeah, anyone. If you are an Arab, you will write it in Arabic. If you are a German scientist, you will write it in German. And so if you are a Japanese scientist, you will write in Japanese. Write it in Japanese. Okay. So you write it in your own language. You write all the steps, and then after your algorithm, you have specified all the steps. These are my steps, okay? I know what are all the steps that should be defined. Which, okay? Once I have finished with this algorithm, it is written in a universal language. To which language am I supposed to go? After the algorithm, you go to the programming language. Okay? Programming language or coding language. So, what is this coding language? This is the next step. First, the algorithm, and then you go to your programming language. So what do you do here? In which language is written this programming language or coding language? What do you mean? Yeah, give me examples. Give me examples. Yes, let's say Pascal. Pascal. Oh, okay. I need a text box. Okay, Pascal. Let's say Pascal. Let's say Python, for instance. Let's say Fortran. Yeah, Fortran. For instance, could be have Java. You have languages, okay? But all these coding languages are written in which language, actually? are written in English. All of them, English, right? Okay, maybe sometimes you don't understand my questions. And then, so first, the algorithm in which is coding in any coding programming language, and it is written in English. Where do you write it? Where do you write it?
Script.
You write it through the keyboard. Okay, my question was so simple. Okay, I write it through my keyboard. Okay, and then after that, what happens? You have finished. You have completed your code. You have written your code and it is ready to run. What is the next step? Yes. Why do you compile it? Why do you transform it in binary language? Yeah. So here you compile. So the next step is to compile. And in that sense, no code, no programming language can run without the compiler. Why? Why is this compiler so required, so necessary? Because your compiler is the translator of all the instructions that you have written in any programming language to machine language. Okay? Actually, we call it machine language or binary language. A machine language, a priori, it is called a machine language. This means that this is the language that your machine will understand. Okay? And a machine language is a binary language. What is a binary language? Okay, this is a language that is composed of a series of 0 and 1. Why? What do they mean, this series of 0 and 1? Yes, and these on and off switches correspond to what, actually? Yes, and much smaller than that. Much smaller than that. Electrons, yes. Let's say I have a lamp, okay? This is my lamp. And here I have a switch. I'm sorry. I need to silent profile, excuse me, sorry. Okay, so here I have a switch that can turn off or turn on the lamp, okay? If I turn it on, the electron will pass and the lamp will switch on. If you have light, the information that corresponds to light is true, okay? Do you agree with me? Do you understand? So I have the lamp. The lamp is on. This means, okay, this means that you have light. If you have light, this means that information is true. This means that the value that is the information will be true. And information is true. This means that my variable is equal to 1. Okay? Is it clear? Can you hear me?
Yes. Yes.
Okay. Yes. So now, if I switch off the lamp, my lamp is off. You have no light. Okay? No light. Information is, yeah, false. False. And the value of my variable will be equal to 0. Actually, all the instructions that I give in my code, in any programming language, need to be translated to these values, 0 or 1. Okay? And this is the machine language. Is it clear? Is it clear?
So basically, it's a bunch of trues and false.
Yeah. With regard to the election, as physicists, you are supposed to know already that when you say computer science, basically it is associated to which other field of physics?
Quantum mechanics.
No, not yet. Electronics, okay? And when you say electronics, basically it is associated to what?
Electrons.
Solid.
Yeah, of
Basically
course,
solid.
electrons, but to which kind, which field of science? How it started?
Could you elaborate?
When you say, excuse me, yes?
Could you elaborate?
No.
Your question. Your question. I didn't understand your question.
When I say computer science, this means electronics. When I say electronics, this means basically, before studying electronics, what do you study?
Les circuits.
circuit.
Diode.
Yes. Circuits. Yes, circuits.
Solid physics.
No, this is not solid state physics.
Electricity.
Automatism. Okay? When you say automatism, you know it.
It's not
Did
in
you hear
our
about
field.
that?
Yes.
It's not in our field.
I think yes. Maybe you have done it in no. This is not your field. When you say computer science, let's explain it in French. How do you call it in French? What does this mean? No, not the study of the information. When you say informatique.
Programming.
Non. Traitement automatique
Théorie de traitement
de l'information. Traitement automatique de l'information. Automatic treatment of the information. Okay? Traitement automatique de l'information. What does this automatic mean? It is based on automatism. And automatisme, la science de l'automatisme, l'informatique est basée sur l'électronique, mais l'électronique en elle-même est basée sur l'automatisme. On ne peut pas commencer à étudier l'électronique sans faire part de l'automatisme aux étudiants. Et l'automatisme en lui-même est basé sur l'algèbre de Boole. Je pense que vous connaissez, l'algèbre de Boole est basée sur la logique. C'est pour ça que je vous ai dit, vous l'avez fait au lycée, vous avez étudié la logique au lycée. OK? Traitement automatique de l'information, mais par rapport Avec quoi? En utilisant quoi? En utilisant l'électron. Maintenant, en tant que physicien, vous savez, alors l'une a parlé de quantum mechanics, but before quantum mechanics, I will say, what do you have? You have electronics, to say that the electron is responsible of taking an information from one place to the other, from point A to point B. And beyond the electrons, what do you have? For transporting an information from one, yes, excuse me? What do you have?
Magnetic field.
No, I'm not talking about that.
Electromagnetic.
Je suis en train de parler, non, je ne parle pas de l'électromagnétisme. Je suis en train de vous dire, quand je dis électronique, le traitement informatique de l'information, l'automatisme et tout ça est basé sur l'électron. L'électron est passé, la lampe s'allume, l'électron n'est pas passé, la lampe ne s'allume pas. D'accord? C'est le transport de l'information via l'électron. Mais maintenant, au-delà du transport de l'information via l'électron, on est passé, when you said quantum mechanics, this means that we are using, yes?
Physics. Statistical physics.
Non, statistical physics, non. C'est la physique des particules. Alors, au-delà de l'électron, beyond electrons, what do you have? You have photons. La photonique. La photonique, c'est le transport de l'information via le photon. Et au-delà de la photonique que vous avez, et tout ça, c'est avec la physique quantique, c'est en rapport avec la physique quantique. Je vous le dis en tant que physicien. There is some noise. Omeima, can you turn off your mic? You turn off your mic. Yes. Okay. So are you still with me? I'm not hearing anything.
Yes.
Okay. So you have electronics, and then after electronics, we have photonics, and then after photonics, you have phononics. Okay, you are studying solid state physics, and you are supposed to know what are phonons. I think that I have already defined phonons last year when you were a second year student, right?
Absolutely. We talked about it in the first
semester in solid state physics. Okay, just to say that for this computer science, you need a hardware. You need matter, okay? Matter is made of atoms, and you can also need photons, you can also need phonons, because everything actually is taking place inside this machine, okay? Inside your computer. This is why we need to compile any programming language. This is why we need to translate any programming language to machine language. So this series to 0 and 1 means that the election passed or didn't pass. Explain. So we have 3 steps. We have the first step during the algorithm, you write the algorithm. Second step, programming language, and last step is machine language. Once you have compiled your code, your program. Now, if you have successfully compiled, usually when you have finished to write all the instructions, you compile step, that is compiling. Once you have compiled your program and that you receive the information that your program has been successfully compiled, what does this mean?
The algorithm makes sense.
Me? Could you understand?
Your algorithm makes sense.
Not really. So I repeat, once you have finished to write all the instructions and that you compile your code, okay, you will receive an information. Maybe you will not receive it. You receive the information that your program has been successfully compiled. What does this mean? What is your computer trying to tell you? Yeah. Does this mean that your program is correct?
No.
Katya. This doesn't mean that
No.
your program is correct. For instance, you are, yes?
It doesn't mean it's correct.
Yes. Otherwise, what does this mean? In the square plus bx plus c equals 0, you could make a mistake actually. But your computer will not realize, okay, that you have made any mistake. When you receive the message that your program has been successfully compiled, this means only that the compiler could translate all the instructions from the programming language to the machine language. Okay? That is all what it means. I repeat, once you receive the instruction that your program has been successfully compiled, this means only that the computer, or the compiler, excuse me, could translate all the instructions from the machine language to, from the programming language to the machine language, okay? Your program is ready to run, but this doesn't mean that you didn't make any mistake to solve the equation. Is this clear?
Yes.
Let's go back to the whiteboard. Now, actually, I'm giving you today all the basics to understand, to run, how to understand the instructions. So we were comparing a recipe to an algorithm. When you say a recipe, so we have talked about the ingredients, okay? And here we have said that these ingredients actually were the objects that were to be defined for solving any problem. I am solving the equation ax squared plus bx plus c equals 0. So I'm starting the declaration part by what? I start by declaring the constants. What are my constants? Okay, so you are supposed to write the whole term, constant. But in Pascal coding, yeah, I forgot to mention something. I will go back to it. So in Pascal coding, you just write const like this, okay? And without underline, of course. And your computer will understand that you are declaring a constant. What are the constants that are to be declared? Yes, A, B, and C. How do you declare a constant? Since we have already explained that once you declare a constant, it will correspond to locked memory cell inside your memory, inside your computer. So how do you declare a constant priori? Okay. Okay. Yes. Yes. Very good. When you declare a constant, you give the name of the constant and the value. Okay. Otherwise, it will not be declared as a constant. This means that I will say A and then. Yes, I'm listening to you. Equals. Okay. A equals to, give me an example. Okay, so just to explain that if you declare a constant, you are obliged to specify its value. So A equals, okay, sorry. If I declare constant, I am obliged to specify its value, okay? So A and then B equals to another value 3, for instance, okay? These instructions are separated by this, or to be ended by this punctuation. It is called semicolon, like this. I don't recall. C equals 1. I have declared all the constants, right? Right or not? So, after declaring all the constants, I will declare the variables. So here, the constant are declared. After this step, I go to the variables. When I declare a variable, I just mention var. Okay? What are my variables? So, let me remind you that I'm solving the equation ax squared plus bx plus c equals 0. So the constants are a, b, and c. How many variables do you have? Okay. How many variables do you have? One variable. Okay. How do you declare a variable? Yeah. Okay. So I declare the variable by the name, okay, and about, and then by the type. Why? Why do I have to specify the type of the variable? I will give you all this through a PDF file. Okay, so I have x, and I declare type. I am obliged to declare the type of the variable. Why?
Could be complicated.
Excuse me?
It's because it determines the values that this variable can have, the operation that the computer can perform on it.
Before that, before the values and before what did we say? When you declare a variable, what does this mean for your computer?
More space. It books room.
Yes. Variable, yeah, it books a room, and it is absolutely important to know the type of the variable in order to know the space, the size of the space that is to be booked for this variable. For instance, if you declare an integer or a real, which one will take more space? Yeah, the real number will take more space than the integer. Okay, is it clear?
Yep.
Okay, so how many types of variable exist. Can you define them? Yeah. Yeah. What is the difference between float and real? If you say float and real, what is the difference? Float and real, Katya. No difference between float and real. Actually, it means the same. Yes, Katya, is exactly the same. I'm asking, what are the types of variables that are known a priori by your computer? You said just open a text box, okay? It doesn't work. Yes, maybe it works. It works. When I say integer, what does this mean? Integer.
Like whole numbers?
We write it. Integer is entier naturel, okay? Is it clear to everyone? You write it like this. Okay? I prefer this. Okay. When you say integer, this is the first type. Ce sont les entiers naturels. 1, 2, 3, and it could be also -1, -2, -3. Next type. So this is the first type. What is the next type? We don't say float. We say float is not a type of variable. It is real. Yeah. It is real. Real. Next type is real. Let me just write it in capital letters. Real. Okay? And in this real, when you declare the real, you will precise for, will precise for the float, or how many numbers after the comma, for instance. Is this real defined in simple precision or in double precision, for instance? Okay, but basically it is a real type that is known by your computer. And now, depending on the language, you have this float notion, this simple precision, double precision, and if you say, for instance, double precision, it will require more space than simple precision number. Excuse me. Is it clear, Katya? So actually, this float is associated to the real type. Next type. Boolean type. I have just explained, I think. What is the Boolean type? Yes. Boolean type, I have already talked about l'algèbre de Boole, ok? Dans l'algèbre de Boole, il porte le nom de Boole. Boole is a mathematician that started with this logic science, okay? And when you say my value is of Boolean type, this means that it could take either 1 or 0. The value that it takes is either 1 or 0. Okay? Is it clear to everyone? Is it clear?
Yes.
Okay.
مدام اسكو هذه
Next.
تاع الطابلو دو فيريتي اللي قريناهم
Voilà, exactement, exactement.
D'accord.
Ce que vous avez fait dans l'algèbre de Boole, vous avez les tables de vérité et vous avez les tableaux de Carnot. Les gens qui ont fait électronique ou automatisme, ils ont fait tout ça. D'accord? Et justement, les tables de vérité marchent avec les variables booléennes. Les variables booléennes, en fait, ce sont des propositions. D'accord? On n'appelle pas ça la variable booléenne. Qu'est-ce qu'elle représente en fait? Comment je la définis? Je la définis comme une proposition. Ça veut dire, et dans cette proposition, c'est quoi? C'est une phrase qui peut prendre la valeur de 0 si elle est fausse ou la valeur de 1 si elle est juste. D'accord? Et ça fonctionne justement avec les tables de vérité et avec les opérations logiques. Are there any other questions? Are there any other questions? Okay, so next type. Yeah, before the string, you have the character. Okay. Character. Okay. What is character? What does this mean? You say character. What does this mean?
Like single letters.
Yeah.
Like it represents itself.
Like letters, vowels, numbers.
Yes, like
all
it
this.
represents itself.
Yeah. When you say character, and in French it is caractère. This means any letter. Okay. This means A, B, C. This means also any number. You can take numbers. These are characters. OK? Donc, quand je dis caractère, ça correspond à n'importe quelle touche, bon, bien sûr, dans les lettres de votre clavier. OK? Mais c'est considéré comme étant tout seul. A tout seul, B tout seul, 5 tout seul. OK? And then, next type. Yes. A priori, not. It doesn't make difference. But for Fortran, it is very important. If you say A or capital A, it sounds different for your computer. Okay, that depends on the language. Yeah. Let me just open a bracket because you have asked this question. Why do they teach you algorithms and why do they practice this algorithm through Pascal coding? Actually, all the universities, most of the universities teach algorithm with Pascal coding. Why? Do you know something about Pascal coding? It looks like with which language actually? It is close to which language? Yeah. Pascal is the closest language, is close to C, and C is the closest language to the machine language. OK? Je répète. Pascal ressemble beaucoup à C. Et maintenant, il ressemble de plus en plus à C. D'accord? Dans ses instructions, dans sa façon de marcher. Et maintenant, Pascal, moi, ça fait longtemps que je n'ai pas fait de pratique pour les étudiants, de TP pour les étudiants. Et je me suis rendu compte il y a 2 ans qu'il y avait même, comme pour le langage C, une librairie qui devait être définie avant de commencer à coder. D'accord? Ça serait intéressant de télécharger Pascal et de faire quelques applications parce qu'il est très proche de C. C language is the closest to machine language. Okay? That's why most of the softwares are written in C. Okay? For instance, when I say softwares, for instance, MATLAB. MATLAB is a software and it comprises codes that are written in C language, okay, a priori. Is it clear?
Isn't Python the new, like the easiest one, the least complicated one?
Python is not complicated. It is the easiest, actually. But this doesn't mean that it is the closest to the machine language. When you say, when I say the closest to the machine, this means that compiling it will take no time at all. Okay? Python
okay.
is easy in coding, in writing the instructions, but this doesn't mean that it is close to machine language. When you say close to machine language, I talk about the feasibility of compiling, of translating the instructions. So C remains the closest. Excuse me? Yes. When you say high level language, it is high level because they make it easy for you to code, okay? But it could be very far from the machine language. Okay?
All right, thank you.
You're welcome. So, next type. What is next type of variables? The string. When you say string, this means? Yeah, series, associations of characters. This means terms, words. Okay? When I say character, this A, B, Q, P, for instance. When you say string, in French, it is la chaîne de caractères. Chaîne de caractères veut dire ça constitue un mot entier, des mots entiers. Okay? And all these types of variables, are there any other types of variables? Are there any other types of variables? No, actually, you are right. Excuse me? Excuse me, what did you say?
I said normally كاين غير 5.
Voilà, كاين غير 5. Okay, so actually there are only 5 types of variables that your computer knows. Okay, sometimes the students answer complex numbers. Complex numbers are not known, are not defined by your computer. Okay, are not defined, sorry, for your computer. Okay. So these are the types of variables that your computer knows. So if you define all these variables, this means that your computer is able to assign a cell memory to any kind of these variables, but to no other kinds. Okay. If we talk about the spare parts of your computer, what are the spare parts? What are the main parts and let's say the auxiliary parts in order to understand something? Yeah, I'm talking, of course, when I say spare parts, this is, yes, for the hardware. Could you repeat, please?
Yeah.
Let's say the CPU.
And the GPU. Right.
The CPU and the memory. And in the memory, of course, you have the RAM and the ROM, okay? There are some exchanging processes between the CPU and the memory. But actually, what works, in that sense, you were right. Okay, so here, this is my memory. I have the ROM, as I have already explained last year. And you have the RAM. Say the RAM. So let's remind who were not with us last year, what does these two terms mean? When I say ROM, this means memory. What does this mean? Yes. Which kind of information, Katya? Which kind of information? No. You have some other kinds of information. When you say read-only memory, there are some information that you can extract from this memory that are stored in this memory, but which kind of information actually? Oui, c'est de la mémoire morte. C'est de la mémoire morte, ça veut dire je ne travaille pas avec. C'est de la mémoire morte. Mais a priori, pourquoi mémoire morte? Je ne peux pas l'utiliser pour mes calculs et tout, mais c'est une mémoire où sont stockées des informations qui sont relatives à la construction de votre machine. D'accord? Parce que si votre machine tombe en panne, je dois savoir exactement qu'est-ce qu'elle contient. Quelles sont ces informations, Katia? La carte mère, la carte réseau, la carte graphique. Tout ce type d'informations indiquées dans la ROM. OK? C'est les informations qui sont mises par le constructeur de la machine. D'accord? Vous pouvez y avoir accès, mais en aucun cas vous pourrez les modifier parce que ça sert à rien de les modifier en fait. Il vous dit voilà comment j'ai construit ma machine. Les histoires de bits, c'est relatif à la RAM. When you say RAM, yeah, random access memory. Si la première est une mémoire qui est morte, celle-là, c'est une mémoire qui est vive. On l'appelle la mémoire vive, on l'appelle aussi la mémoire volatile. Ça veut dire si vous n'avez pas sauvegardé les informations qui sont relatives à vos tâches, elle va disparaître, elle va partir. OK? Donc pour la garder, il faudra penser à sauvegarder. Ça, c'est la mémoire. Quand je dis c'est la mémoire, ça veut dire c'est le terrain de jeu de votre ordinateur. Et quand je dis ordinateur, je parle des processeurs. Ça veut dire si je veux améliorer, if I want to improve my computer, the quality of my computer, I need to improve the number, to increase, the number of processors. And I also need, in parallel, to increase the space in which these processors will work. Okay? Is it clear? So, si je veux améliorer les performances de mon ordinateur, je dois jouer sur le nombre de processeurs, mais ça ne sert à rien de jouer sur le nombre de processeurs si, a priori, vous n'avez pas augmenté l'espace de jeu. C'est là où va jouer les processeurs. C'est là où ils vont travailler. Donc, si la RAM n'est pas augmentée, vous n'avez pas augmenté les performances de votre ordinateur. Et donc, au lieu, si par exemple, on va dire 7, j'ai un i7 ou, je ne sais pas, i9 ou j'ai par exemple 12 cœurs à l'intérieur de ce processeur et qu'il n'a pas où travailler, je n'ai rien fait. D'accord? Donc, ici, quand le processeur est en train d'effectuer des tâches, il va avoir besoin d'un maximum d'espace pour stocker les informations. Parce que quand il est en train de calculer, il est en train de stocker des informations au fur et à mesure. Et donc, si vous n'avez pas augmenté la RAM, ça va lui prendre beaucoup de temps. Par exemple, il a 2 ou 3 cases mémoire dans lesquelles il peut stocker. Vous pouvez imaginer qu'il va prendre beaucoup de temps. Il va stocker. Ensuite, dans le prochain pas, il va écraser les valeurs et passer à l'étape suivante. Alors que si vous avez augmenté la RAM, il n'a pas besoin d'attendre. Le temps de calcul sera nettement amélioré. Donc, le temps de calcul, le temps machine est amélioré en jouant sur la RAM et aussi sur le nombre de processeurs. OK? I say the CPU. You have here 2 parts. 2 units, actually. You have unit 1 and unit 2 in the CPU. Unit 1 corresponds to what? So this represents the processors, the CPU, okay? But inside your processors, what do you have actually? You have 2 units. The first unit corresponds to what? Donc, par rapport au processeur, vous avez 2 unités principales. Le processeur est constitué de 2 unités principales. D'accord? Quelles sont ces unités? Pour ceux qui ont fait un petit peu de programmation ou d'informatique, quelles sont ces unités? Pour dire de quoi est constitué, oui? De quoi est constitué mon processeur? Je vous écoute. No idea? Are you here? Okay. So, the first unit that corresponds to arithmetic and logical operations, okay? All the operations are treated here in this unit, okay? By this unit, actually, okay? For the space, it is in the RAM. For the second unit, it is called the comment unit. Nous avons 2 unités principales, et c'est tout ce qu'il y a dans le processeur. Vous avez l'unité arithmétique et logique qui va contenir tous les types d'opérations, qui va se charger de tous les types d'opérations que va faire votre ordinateur. Quand je dis opération, vous avez les 2 types d'opérations, arithmétique et logique. Dans les opérations arithmétiques, qu'est-ce que vous avez? Yes. Multiplication, division, okay? Subtraction, okay? And for logical operation, what do you have? Donc, je répète, ici, vous avez 2 unités. Une unité qui est appelée unité arithmétique et logique, où vous avez toutes les opérations arithmétiques et logiques. La deuxième unité est appelée l'unité de commande. C'est elle qui va se charger de donner les instructions et de récupérer, d'envoyer et de récupérer des informations. D'accord? C'est l'unité de commande. Maintenant, pour les opérations arithmétiques, nous avons dit c'est l'addition, la soustraction, la division, la multiplication, bien que peut définir à la base 2 opérations, en disant que la soustraction fait partie de l'addition et que la division fait partie de la multiplication. D'accord? Diviser un nombre par 3 veut dire qu'on l'a multiplié par l'inverse de 3. D'accord? Maintenant, pour les opérations logiques, qu'est-ce que vous avez comme opération logique? juste pour savoir comment travaille votre ordinateur et de quoi, quelles sont les limitations de votre ordinateur. Qu'est-ce que vous pouvez faire avec et qu'est-ce que vous ne pourrez pas faire avec. Logique.
Madame, هذيك تاع ou et pas, je sais pas.
Yes, yes.
L'addition logique et la négation logique, je pense.
Voilà, voilà. Logical operations actually, and basically, you have the and, the or, what do you have? The negation and the XOR, 4 logical operations. Let me...
if.
No, this is not an operation. No, I'm supposed to yes. So among these operations, you have, I was like, excuse me, okay, and will correspond to what? To which operation?
Addition.
No. It corresponds to the multiplication. You will see how. Okay? And the next operator is the OR. Yes. And then
la négation.
Yes. You have negation. And what do you have also? No. Almost there. I have already talked about it. Yeah, XOR. Exclusive OR. Okay?
Ou X and.
No. This doesn't exist.
Parce que normalement, bon.
Je vous dis pour l'ordinateur, quelles sont les opérations logiques qui sont... Je ne comprends pas ce qui se passe. Voilà. Like this. OK. C'est les opérations logiques que connaît votre ordinateur. OK? So, these are the 4 logical operations. You have the AND, OR, negation, and XOR. How do they work?
Chacune représente une opération, je pense.
Mais justement, on a dit, le AND, il correspond à la multiplication.
Oui.
OK? Le OR va correspondre à l'addition. En fait, pour les ensembles, dans la théorie des ensembles, le AND correspond à l'intersection et le OR correspond à la réunion. OK? So, 2 variables. I have A and B. Okay. How do these operations work? To perform it with you, I have a PDF file that I intend to send you. Let's say here, it is not that easy. A and B. A and B. Okay. So the possible values that can take A and B in the same while. A can take the value 0 or 1. B can take the value 0 or 1. But if they are together, what are all the combinations? How many combinations do you have for A and B? 4 combinations, okay? In the first one, both of the 2 values of the 2 variables are false. So I have 0 for both of the 2. What is the value of A and B? So the logical operation and means that the result is true if both of the two informations are true. So for the first one, the first result is 0. Okay? And then next combination, you have 1 for A, 0 for B. What is the result? Because the end means the result is true if both of the two information are true. Next combination, 0 and 1. The result is 0. Okay? Last combination, 1 for A and 1 for B. The result is 1.
Right. Yeah.
Right?
Yep.
Okay. So, yes?
Nothing.
Yes?
Madam, sorry to interrupt, but we have another session in like 5 minutes, so we have to. Yeah.
I'm sorry. Okay. So, see you next Thursday, excuse me. They have told me about the possibility to teach you at the university. Can you find me a room?
We don't know because it's actually the administration's job.
I thought with the students of section B, I heard that the students were organizing the schedules in order that all the teachers can find a time or a room for teaching.
Yes, madam.
Yes, but the administration refused that.
دقيقة أميمة. كاين اللي صار تاع لي نوفو بلوك. البارح قرينا فيهم بون هضروا معاهم لي زيتيديون اللي راهم يورغانيزيو لي سال اكسيتيرا. قعدوا هضروا مع تاعهم تاع لي نوفو بلوك هذوك تاع السي والدي. They are always free. شغل راهم دايما فري بصح كاينين شغل دي بروف وما بعد جوغ يجيو يقريو تاني ربما يقريو اون لين يقريو بريزونسيال دونك we can find إذا لقينا دي سال تما libre we can go and see if like they are free.
Madame.
Yes.
Madame.
Yes.
Pour le modèle d'anglais et découvert pour le moment رانا خليناهم en ligne le jeudi.
خلاص d'accord, ok, c'est comme vous voulez. On avance, oui.
كما تسمى حبت دير بالخميس بالك نشوفوا كيفاش تسمى إلا
je comprends.
Je crois justement ما جايش نديروا العجل موديل واحد.
Oui, je comprends. Oui. Je comprends parce que vous avez les deux modules en ligne. Khlas, je comprends. Sauf que, bon, ça me permet de... Oui.
شغل madame, si on a trouvé شغل إلى قرينا les deux autres modules en présentiel, on peut شغل نجيبوا le module anglais نقدروا نكملوه en présentiel. Mais si c'était pas le cas, on peut pas شغل sacrifier deux modules.
C'est clair, c'est logique. D'accord, c'est clair, je comprends parfaitement. D'accord, ok. Donc, see you next Thursday, Inch'Allah.
Inch'Allah, merci madame. Thank you.
Ok, voilà, you're welcome. Ok.